So in this lecture, we will continue our discussion on logarithm. We will study some more properties of log apart from what we studied in the last lecture, right? In the last lecture, we discussed about these two properties where log 1 to the base a is equal to 0 and log a to the base a was equal to 1. And I also mentioned that whatever is written on the left hand side, we are assuming that it is defined, right? And for log b to the base a to be defined, we said that b should be greater than 0, a should be greater than 0, and a should not be equal to 1. And these three conditions should satisfy simultaneously. So the next property that we are going to study here, the next property, or let us say property number third that we are going to study here, is a raised to power log b to the base a is nothing but b. Okay, so if you see an expression like this where this a and here the base of this log, which this expression is in the power of a, right? And the base of this power is also same as this base. I hope you understand. For example, let me write something else. Let us write c raised to power log c, and let me write b here. In this case also, we can write it directly as b, right? Let it be our property number third. So we can prove it very simply, right? This is simple observation. Let us say if I consider log b to the base a as k, okay? So from the basic properties of log or the basic definition of log, what can I say is that a raised to power k is equal to b. Yes, because this is the definition of log. If I have written this, if I take log b to the base a as k, what can I say from the basic definition? That I should raise this base a to power k to obtain argument b. So I have written a raised to power k equal to b. And what is k? K is nothing but this expression. So in the next line, I'll write a raised to power this log b to the base a is equal to b, right? So this is a simple observation, this property number 3. Okay, so let's move to the next property, property number 4, or we can call it a product rule also. So if there is a product, let us say log m into n, right, and the base is a, so we can write it into summation form, log m to the base a plus log n to the base a. So this is a very powerful property which simplifies our calculation, right? This was in multiplication form, and this property, property number 4, has brought it into summation form. Okay, so in a way it has simplified our calculation because you can take more numbers also. Let us take p1 into p2 into p3 into p4 into, let us say, n such numbers. So this will convert it into this form, log a p1 plus log p2 to the base a log p3 to the base a plus and so on log pn to the base a. So it can convert these multiplications into summation form. Alright, so how to prove it or how to think about this property? Let us see. Let us clear the board first. Okay, so the property was log m into n to the base a is equal to log m to the base a plus log n to the base a. So I am going to prove it by taking this expression as x and considering this as y. So if I consider log m to the base a as x, then from the basic definition I can say a raised to power x is equal to m. A raised to power x is equal to m. And I have taken log n to the base a as y. So from the basic definition I can say a raised to power y is equal to n, right? Now if I multiply a raised to power x with a raised to power y, a raised to power x with a raised to power y, what will I get? I'll get m into n. That is a raised to power x plus y is equal to m into n. Now again I'll use the basic definition. Here it is something written in exponential form, right? A raised to power something is equal to something. So what can I say it in language of log? See, in the beginning we said a raised to power x is equal to b. So what did we say? That log, this a will go into this base and this is the argument and this is the result. So log b to the base a was x, or in other words we said to what power should I raise a to get b? So it was x. So here if I use this same definition, to what power should I raise a to obtain mn? And I write it in language of log. So base should be a and argument should be mn, and it is equal to power x plus y. So to what power should I raise a to obtain m into n? So obviously I should raise a by x plus y to obtain m into n. This proves the property because x is nothing but log m to the base a. X is nothing but log m to the base a, and y is nothing but log n to the base a. So this property that we talked about is proved, right? Now I can take any number of terms here and it will convert it into summation form, right? We said this in the beginning of this lecture. Now if I take, let us say, log b raised to power n and the base is a, okay? So how can I think about it? That log b to the power n to the base a can also be written as n log b to the base a. That is, the power of this argument, which is n in this case, can be taken outside. The power of the argument can be taken outside. How to think about it? Think about this expression. Log, the base is a and this is b raised to power n. So the argument basically is b into b into b into b into so on n times, right? So argument is written in product form here and it is b into b into b into b n times. So the rule that we just studied will convert it into summation form, that is log b to the base a plus log b to the base a plus log b to the base a, and how many times? N times, obviously. So if I add the same expression n times, I can simply write it into n into log b to the base a, right? How many times this same expression is being written here? N times. So I can write it simply as n into log b to the base a, right? So the power of argument I have taken outside. I hope this rule is clear to you, right? So till now we have studied that log 1 to the base a was 0. Second, log a to the base a is equal to 1. Third, log a to the power k to the base a is equal to k. Then fourth, we studied log m into n to the base a can be written as log a m plus log n. And fifth part that we studied was log a. Let us say I write b raised to power k here, so I can take this k outside. So the rule is k into log b to the base a. Right? This much should be clear to you, and in the next lecture we will continue this discussion. Okay.